Hello everyone. In this session we are going to see the basics of vectors. See, in our last session we have defined what is meant by vector, what is meant by scalar, and what are the different components in vector. So in this session we are going to see the components or different types of products or different types of methods involved in the vector algebra, right? So see here, generally, in our last session, we have seen how a vector can be projected into the three-dimensional axis, right? So, how a vector can be projected into three-dimensional axis in the sense three-dimensional platform. So, a generally three-dimensional plane should have three different components, three different axes, that is x, y, and z, right? See, listen carefully. Here also we are having the same three axes, that is x, y and z, right? This is my vector A vector. So now I am going to project this A vector in the x, y, z plane. See here, we are going to just convert this ax, ay and az in terms of theta and phi. In terms of theta and phi. These two are the radial components. These two are the radial components where theta represents how the A vector is shifted from the z axis, right? Whereas this phi represents what? What does this phi represents then? You have to mention it in the comment box. What is the meaning of this phi? What does the meaning of this phi? In our last session I have explained what is the difference between theta and phi. Actually, theta is the direction of the vector along which the direction, at which direction the vector is moving. So that is said to be the theta. Whereas what is meant by this word phi? This phi represents what? Okay. In our last session I have explained what is the angle between any two components represents this phi. Okay, you have to mention it in the comment box. See here, then generally how can we find out the magnitude of any variable? So magnitude can be found out by the formula of square root of its individual squares, addition of its square. So ax squared plus ay squared plus az square. Then theta. Theta is equal to cos inverse of az by ax. Then phi is equal to tan inverse of ay by ax. Tan inverse of ay by ax. See the same thing happening over there. Already we have seen a right triangle. In our last session itself I have explained you how can we find out the angles and basics for all right triangle components. See here I am considering this is theta. Okay. So now find cos theta is equal to what? Cos theta is equal to adjacent side. This one is our az component. Okay. And this is our ax and this is our ay. So az divided by ay. So az is our adjacent side and ay is our hypotenuse. Okay. Then unit vector. Unit vector is represented by this pattern. Ax into I vector plus ay into j vector plus az into k cap. What does this I, j, k represents? This I, j, k represents the direction of these components, direction of these vectors, direction of these individual elements. Okay. What does this I, j, k represents? It is a directions. So I cap, j cap and k cap represents the directions of ax, ay and az. Okay. Okay, then see, this is an example. Which of these show the proper projection of a vector onto the z axis? So ஒரு z axisly ஒரு vector நம்ம project பண்ணனும் அப்படினா, in our last session we have seen how the vector can be projected. எப்படி ஒரு வெக்டாரை ப்ரொஜெக்ட் பண்ணணும் ஒரு XYZ பிளேனில் அப்படின்னு சொல்லி நான் எக்ஸ்பிளைன் பண்ணியிருக்கேன். இந்த வீடியோவில் இந்த செஷனில் நான் ஒரு கொஸ்டின் கேட்டிருக்கேன். 3 டிஃப்ரென்ஸ், அதாவது 4 டிஃப்ரெண்ட் பேட்டர்ன்ஸில் நான் ஒரு வெக்டாரை ரெப்ரசன்ட் பண்ணியிருக்கேன். Now you have to find out which one is the proper projection of a vector on the Z axis. ஒரு Z axisல ஒரு வெக்டாரை ப்ரொஜெக்ட் பண்ணுறதுக்கு எது கரெக்டான ஃபார்மேட்? So you have to select option A, B, C, D or none. Okay? You have to mention the question number 7 in your comment box and answer it. Okay? Okay. Okay then. So right hand coordinate systems. See which one is the right hand coordinate system. A three-dimensional coordinate system must obey the right hand rule. Must obey the right hand rule. What is mean by right hand rule? Curl the fingers of your right hand. How can we curl the fingers of a right hand? So this is the curling the finger of a right hand. Okay, curling the finger of the right hand means you have to fold your hand like this. We used to say it is thumbs up, right? So likewise we have to keep our hand like this. So by curling the finger of your right hand, so they go from X to Y. How the fingers are moving? It is moving from X towards Y, right? It is moving from X towards Y. Have you all understood what I am saying? See, listen carefully. Curl the fingers of your right hand. I am just folding the fingers of my right hand and keep it as in the form of thumbs up, right? And keep it as in the form of thumbs up symbol. So my fingers are folding in this direction, that is from X to Y. So your thumb, so this thumb will point in the Z direction. This thumb will point it in the Z direction. Okay. Now see how the X axis is moving towards Y axis, and this thumbs up symbol represents this Z axis. Okay. Okay. Which of this coordinate system obey the right hand rule? So X, Y and Z. See here, X and Y, and the top direction is here Z direction. So see this question. Which of these coordinate system obey the right hand rule? Whether X, option Y, option 2 or option 3 or option 4. Now we have to find out which option represents the exact right hand coordinate system. Whether 1 and 2 or 2 and 3 or 1, 2, 3 or 1, 4 or 4 only. Okay. Please put the question number, this one, and answer it in the comment box. Okay. Then vector mathematics. First see vector inverse. What is mean by vector? How the vector can be represented? A vector is generally represented like this. It is a normal vector. Whether if it is a vector inverse, what does this statement represents? We are just switching the direction. So what is the direction of this vector? It is focusing in this direction. Okay, this is the normal vector, A vector. If this is a vector, now I have to find A minus A vector. Now I have to find minus A vector. Then the direction will be like this. It should be in the opposite direction. Just switching the direction. Okay. See here. So A vector in the sense, see here, A vector is focusing, A is focusing in this direction, whereas minus A focusing in the reverse direction. Okay. So this is the first property, that is vector inverse. Now we will see some properties of vector mathematics. So first property is vector inverse. Vector inverse is nothing but just switching the direction of the vector. Whether whether A vector is focusing towards upwards, then the minus A vector will be focusing downwards. Okay. Then the second property is vector addition. Vector addition. It uses the head and tail method. Head and tail method or parallelogram method. Head and tail method or parallelogram method. See, here we are having A vector, B vector, and the hypotenuse is A vector plus B vector. So it is just the addition of two components. The hypotenuse is the addition of two components, A vector and B vector. Okay. See here how the parallelogram is forming. Listen carefully. Once again I will explain you. See this point. First B vector is added and then A vector is added. After that the B is moving towards the top angle and A is splitting over the right hand side. Then what happens? We are splitting a single parallelogram into two triangles, two right triangles, by keeping a central line, that is yellow line, as a common line, common hypotenuse for two triangles, two right triangles. Okay. So this is up to vector addition. Then we will come to the third property, that is vector subtraction. Vector subtraction. So by using this inverse property, we can easily find out the vector subtraction. So first we need to find vector inverse. After that we just want to add these two vectors. See here we are having A vector, then B vector, then we have to find minus B vector, then add A vector plus minus B vector. Okay. So this is about vector subtraction. Then our fourth property is vector multiplication. See, this plays a major role in vector algebra. That vector multiplication consists of two important types. One is scalar product and the other one is vector product. So scalar product is also called as dot product and vector product is also called as cross product. Okay. So there were two types of vector products, vector multiplication, that is scalar product, dot product, vector product or cross product, right? So in an upcoming session we will see this vector multiplication in detail. Thank you all. Thank you for watching this video. If you are having any doubt, please post it in the comment box. Do complete all the exercises I have given in this session and do upload your answers in the comment box. Thank you all. Thank you for watching this video.